Hey everybody, I'm Frank and this is Micro-8, a 8-bit homebrew computer that I've designed and built from scratch. In this series of videos, we are going to explore everything there is to know about this computer, starting today with an overview of the system, how it works and what it can do. Let's get started. There it is. Micro-8 is hooked up to the monitor and the capturing device, so you can see what I'm doing on the screen. As you can see, the prompt is very reminiscent of the basic prompt you could have on old 8-bit computers of the era, and that's basically the idea, to have the same user friendliness as the basic computers, but with a more modern language and the ability to access hardware that's been designed for making small games. So you can enter two kinds of commands. The DOS commands, such as dir to see the content of the flash drive, or you can type in language commands, such as creating a variable, assigning a value to it, and print, for instance, the content of the variable. So you see, I can use the same interface to interact in both ways. I can create directories, I can copy files and so on, or I can directly try small programs in the interactive prompt to maybe test new ideas. I can, for instance, draw a circle on the screen. The graphics resolution is 400 by 240. So if I want a circle in the middle of the screen, I can type 200, 120. Then I can type the radius of the circle and pick a color in the color palette. The circle is drawn using the bitmap, and the bitmap is in a separate layer from the text. You can see if I scroll or if I type over the circle, it's a different layer. And there are several layers for sprites, tiles, bitmap, and text. Each layer has its own palette of 16 colors, so I can choose one of the 16 predefined colors, but I can define a color if I want to. Now, that's cool, but what if I want to draw many circles? Well, I can, for instance, try a loop with the X value, that will be my moving value across the screen. So it started at 0, for instance. Note that you don't have to initialize a variable, it's initialized by default. While X is smaller than 400, which is the extreme right of the screen, and I can increment that value by steps of, say, 10, okay? So that's my loop. And now I can say, draw a circle at each iteration of the loop at position X, still in the middle in the Y coordinates. Let's keep a radius of 80. And what I want is to have each circle of a different color, right? So we have 16 colors, and I want to loop over each of the colors. I could use X, but X is going to start at 0, that's fine, and will increase by 10. So I will have the first color, then the 10th color. That's not what I want. I want each color, so I will divide by 10, okay? But that I want to repeat. So when it reaches 16, it goes back to 0. So I can use the modulus operator to loop at 16. If I try that, it won't work. And let's see what happens. It will say, okay, there is an error at this line because there is a type mismatch. The language that is being used, which is a custom language built for Micro-8, is called Lofi. And Lofi is a typed language, which means every variable has a type, and there is a type checking system to check that what you use is the right variable for the function. And the circle function, the color here in the circle function requires a byte. And right now x is an integer because I want to move way past the limit of a byte, which would be 256, because I want to draw circles up to 400, right? So I use an integer here. But for the color, once the color value is computed, I want it to become a byte. For that, I can cast into a byte the value that is the result of the calculation here. And now it works. And you can see it's quite fast to draw the circles because although the Lofi language is compiled into bytecode and the bytecode is interpreted by a virtual machine, the actual circle routine itself has been written natively for the processor. So it's really fast. Okay. Let's have a look at the various folders that comes with the computer. So we have some demos, examples. So demos are like larger examples, right? To show off the feature of the computer, and we'll test some. The examples are more like a complement to the manual. The manual is a reference manual. It gives you the keywords for the language, how to set up the hardware, and so on. But then, if you want more examples to explain how to do stuff, that's what the example folder is for. Like, for instance, if we go to graphics, we have tons of examples to show how to create some cool graphics. Simple things like drawing lines or circles like we just did. Maybe some more advanced stuff like this one, to create a function to draw sine waves. And as you see, I just enter the editor because those programs are both available as source code. So you can edit and read the source code to learn how it works, and as executable. From the editor, you can compile, and you can see here some statistics about the code that we just compiled. It uses only 1% of the symbols. Symbols are the names that you give to the variables. The size of the code, it says 0 because it's so small that it doesn't even count. Same for data. Okay. When it's compiled, it ends up as a bin file, and this bin file is only 189 bytes. If you want to run, you can either load and then run, or type run directly, and you can see the execution of the three waves that are called, three functions that are called here with different parameters to draw the different waves. Okay. One cool thing is that you can also compile and run and execute directly from the editor. Function R will compile and then immediately execute. So you can iterate very quickly. Let's have a look at another example, more advanced example, a 3D cube. So you can, this is also bitmap using the line draw the line function to draw lines, but it uses a double buffer system. So it draws the cube and then displays it on the screen. And while it is displayed, the next iteration draws the next cube in the back buffer, and then the back buffer are swapped. So you have the memory to hold 2 frame buffers to create smooth animation using bitmaps. Of course, you are still on an 8-bit computer, so there is no native support for floating point maths. So this is slow. This is slow, but it's fun anyways. There's a small example of redefinition of the character sets in the examples. I think it's the IO, custom glyph. So you can, for instance, use this method to define a new character. It's a small array of text, and then you scan the array of text, and if you find a square, then it's a pixel. The bit is set to 1, otherwise it's set to 0. And if you execute that, that will create this new character, and you can reuse it anywhere you like. To see some more complete demos, so I'll go to the demos folder, and we have a few demos here. I will show this one. This is a small demo that shows all the hardware features, all the graphic hardware features, the sprites, the tile, the bitmap, all together. So you can see the source code is 3.5K, and the executable is under 1 kilobyte. Of course, you can also edit the code and have a look at how it works. This one is a little bit more involved. So how does it work? It loads a bunch of resources, like an image, a tile set, a level for the tile set, and sprites. And then it builds some tables for the sprites, and then you have the main loop somewhere down here that will move, copy from the map the tiles to the screen, move the scrolling offsets, and iterate on that. So although the bin has already been compiled, I can compile and execute from here, so you can see the entire process from the editor. Okay. If you see some stuttering, it's the capture card that cannot keep with the frame rate, but it's silky smooth, 60 frames a second on the actual machine. So this program is a small demo, a small organ to play some sounds that have been created with the sound editor that we will see in another video. This is just a small example to show how to access the synthesizer and play some instruments. Also, it works with a MIDI keyboard. There are 2 MIDI connectors on Micro-8, in and out. If you plug a MIDI keyboard, you will be able to play with this example. If you want to create games on the computer, at some point you will have to create resources. How do we create resources? Well, that's easy. We've got a bunch of tools to do so. Today, I will just show you the image editor. There's a map editor to create levels for 2D games. There's a sound editor to create sounds. And there's the sprite editor to create sprites and animation. Let's have a look at the image editor. You've got various draw tools. There's a zoom mode, so you can work at pixel level for creating pixel art. This image is a work in progress, and I'm using it to get a sense of how the tool performs and to improve it and to add some features. But as you can see, you can already create nice pixel art with the tool, especially using the zoom window here. That allows for very fine control of what you want to do. In the next videos, we'll go deeper into each of the subsystem: audio, graphics, programming. At some point, I'd like to do some live programming, show you how to do stuff. There is also a user port, so I'll show some examples of custom hardware that you can build and connect to the computer. That's it for today. See you next time. Bye-bye.